Question number 12. So a train normally travels between 2 points A and D, which is 12 kilometers at a speed of 30 meters per second. So there's a units mismatch there that I'll probably have to deal with. Okay, so the first question is the time taken. It says it's a constant speed. So we're good just to use the distance speed time triangle. The same would have been the case if it had given us an average speed. It's an instantaneous speed that you have to use more advanced machinery for. So speed equals distance over time. So therefore time equals distance divided by speed. So 12,000 meters divided by 30 meters per second equals 400 seconds. Notice there I just corrected the units mismatch. So it's Roman numeral part 1. Roman numeral part 2 says that there's two other, before Roman numeral part 2 there's more information. Between A and D there's two other points. AB equals 2. BC equals 6. And CD therefore equals 4, which checks out because that would be 12 overall. Now there's a speed restriction of 10 meters per second between B and C. So this section here is 10 meters per second. Now in order to make... Okay, so normally it's 30 meters per second, but this next thing is not normal. Because just on one day there's this speed restriction. Now assuming it's going at 30 meters per second at A, it decelerates uniformly, so that means we can use SUVAT. It decelerates in order to be going at 10 meters per second at B. Then it does its thing at 10 meters per second, and then it accelerates uniformly again, so that by the time it gets to D, it's at 30 meters per second. So I'm just going to take these sections separately so that I can use SUVAT. When I say separately, I'm going to say U equals 30 for this section. So this is just A to B I'm dealing with here. U equals 30, V equals 10. Whereas over here, different separate things, so I'm going to be a bit sneaky and use the same letters twice. U equals 10 and finally V equals 30. The displacement equals 2. The displacement equals 4. I realise, by the way, I haven't read the question yet. It's the time taken to travel from A to B, so I'm going to work on this. I want to know the time. For this one, I want to know the acceleration. That's Roman numeral part 3. Okay, so do I have a SUVAT for that one? Yes, I do. It's so I'm having a mental blank here. What else do I know? I know it's displacement 2, initials 30, finals 10. Oh, so that should be 2,000, sorry, because it's in meters now. And I want to know the time. Just having a mental blank here. So that was me just going to get the solutions, sorry. Oh yeah, it's this, sorry. S equals U plus V over 2 times T. That's a fancy version of the distance speed time triangle, because that's your average speed there. The only reason why that's the average speed, by the way, is because the acceleration is constant, but we knew that anyway because it was a Suvat situation. So therefore 2000 equals 30 plus 10 over 2 times t. So 2000 equals 20t, so t equals 100. So that's Roman numeral part 2, that's seconds. What one is good for this? It's v squared equals u squared plus 2as. So 900 equals 100 plus 2a4. So 800 equals 8a. So 100 equals a. Wait, I've not made a mistake there. Oh, sorry, it's the units mismatch again. 4,000. 8,000. So a equals 0.1 meters per second. We're setting this up as the positive direction, so that's why all my displacements are positive, moving from there to there and there to there. And if we're getting faster in the positive direction, then that's definitely a positive 0.1 rather than a negative 0.1. So that's Roman numeral part 3. Roman numeral part 4. The extra time. So normal time is 400. Extra time is 100 plus the normal. This section is just half of the original, so that'll be a 200. That's just 6 versus 12, so it'll be taking half that normal time, which is 200. And then finally, for this, how can I work out the time? Oh, I'll just use this again. S equals u plus v over 2 times t. So it's 4 equals 20 over t, but that 4 is 4,000, by the way. So t therefore equals 200. So that then goes in there. So it's 500 for the extra, 400 for the normal. Wait on. Normal time is definitely 400, because we worked that out up here. We already worked out the section for A to B is 100. The normal time for B to C is definitely just half the original time for A to D, because it's half the distance. So that's 200. So have I correctly worked out this? Just do this more carefully. 4,000 is the displacement from there to there. The speeds are 10 plus 30 over 2 over t. So it's 4,000 equals 40 over 2t. So 4,000 equals 20t. So t therefore equals 200. I don't know either. My scheme reckons it's 900 altogether, whereas I've got 500. So my extra time is 100. I now realise my mistake. I just figured that this was... Oh, how terrible. Okay. Sure, this is half the distance, but that's not the time for the lower speed. The time for the lower speed is... so I'm just going to do this again for the middle section. So in other words, from B to C. I'm just going to use the distance time triangle again because it's got a constant speed there. Its distance is 6,000. Its speed is 10. So that's 600. So there we go. That middle section is 600. So that's now 900. So the time lost is 500. Sorry about that. Okay, here's question number 13. It's just a solid pyramid, square base, side 20, so that's 10 there. That's 15. So calculate the length of the diagonal AC. So this is a right angle triangle here. Get some colours going. This thing is just chocker with right angle triangles like these questions always are. Draw that out separately. It's this. That's your blue triangle. It's got a 10 there. It's got a 10 there. So x squared equals 10 squared plus 10 squared. X squared equals 100 plus 100, which is 200. So x equals the square root of 200. Oh, sorry, that's 20. If that's 10, then that's 20. It's 400 plus 400 is 800. Square root of 800. Pump that through a calculator, you get 28.3 to one decimal place. Now, show that the length of the AV. Okay, well, here's my purple triangle. Find it. Purple pen. Draw this out separately so it's clear it's right angled. What have we got there? We've got half of this fella. So we worked out that it was the square root of 800. So that's that divided by 2. The height is 15. So call that y. So y squared equals 15 squared plus root 800 over 2 all squared, which is 225 plus 800 over 4, which is 225 plus 200. So y squared equals 425, so y equals the square root of 425, which is what we're asked to show. Calculate the angle that AV makes with the base. Okay, so this is just SOHCAHTOA on this triangle. So that's the angle I'm asked for there, call that x. So, opposite over hypotenuse, sine x equals 15 over y was root 425. So go shift sine fraction 15 over root 425. So that's 46.7 to one decimal place. Roman numeral 4, calculate the length Vn. Okay, red triangle now. So I'm a red triangle. I've got Vn, I'll call that W. VB, I'll call that, that's the same as AV. I'll call that 425 in a square root. And that one is 10. So we go W squared plus 10 squared equals square root of 425 squared. So W squared plus 100 equals 425. So W squared equals 325. So W equals the square root of 325, which is 18.0 to 1 decimal place. And finally, Roman numeral so that's VB. Okay, so this line is when you just scoot straight across the face to get to this at a right angle. So that's my red triangle there, from up there. Okay, so this is using the principle that two different ways to work out the same thing have to give the same answer. The area of the triangle on the one hand, so basically I'm going to work out the area of the triangle twice. So on the one hand, the area is half the base times the height, so the area is, so this is one way of working out the area, 10 times, what was Vn? I worked it out in the previous part. Vn was square root of 325. So it's half base times height. But if you turn it around this way, it's half base times height. So if we call that h, so half base times height. So that's one way of working out the area. That's another way of working out the same area. So double both sides, you get 20. Divide both sides by square root of 425. Pump that through a calculator and that's your h, which is 17.5 to 1 decimal place.